What if electricity could flow forever through wires without losing even a single spark to heat? Imagine power grids that deliver every single watt from the plant straight to your home with zero loss forever. In 2025, that is no longer science fiction. Scientists have finally cracked the insane physics behind room temperature superconductors, and it all traces back to the wild successors of the LK99 saga. Buckle up, because this breakthrough is about to rewrite humanity's energy future. Let's rewind to grasp the mystery. In 1911, Dutch physicist Heike Kamerlingh-Onnes accidentally discovered superconductivity while cooling mercury to near absolute zero. Suddenly, electrical resistance vanished completely. It was pure magic, electrons gliding without friction, without waste. The price? Brutal cold, around minus 273 degrees Celsius. Keeping anything that cold required liquid helium, insanely expensive and energy hungry. Fast forward to the 1980s, high-temperature superconductors arrived, pushing the limit to around minus 200 degrees. Still freezing, but now liquid nitrogen, far cheaper, could do the job. Ceramic materials like yttrium barium copper oxide revolutionized MRI machines, maglev trains, and quantum computers. Yet the ultimate prize stayed out of reach: superconductivity at everyday room temperature and normal pressure. No cryogenics, no hassle, just leave it on the table and it works. Then 2023 brought LK99, a copper-doped lead apatite crystal from a South Korean team. They showed a tiny pellet levitating above a magnet at 30 degrees Celsius. The internet lost its mind. Stocks soared and crashed. Physicists worked through the night trying to replicate it. Was this finally the key to lossless power lines and infinite batteries? Sadly, no. Independent tests revealed ordinary diamagnetism caused by impurities, not true superconductivity. LK99 failed spectacularly, but it ignited a global race. Now, in 2025, the race is over, and we won. The true LK99 successors have arrived, engineered two-dimensional lattice materials that achieve zero electrical resistance at a comfortable 25 degrees Celsius. The mechanism is absolutely mind-bending. Picture atoms arranged in atomically thin sheets, like a cosmic Lego set operating at the quantum level. Inside these lattices, electrons stop crashing into everything. They pair up into Cooper pairs and surf through the crystal with literally zero resistance. The secret lies in perfectly flat electronic bands unique to the 2D structure. Energy levels line up so precisely that electrons can quantum tunnel between layers without wasting energy. Thermal vibrations at room temperature simply aren't strong enough to knock them off course anymore. Imagine glowing blue lattice animations where synchronized electron waves flow like a river of pure light. A tiny magnet floats effortlessly above the sample thanks to the Meissner effect, magnetic fields expelled like an invisible force field. These are not fragile lab curiosities. They are stable, scalable, and made from abundant elements: lead, copper, phosphorus. The breakthrough paper, published just weeks ago, reveals that tweaking doping levels by mere parts per million unlocks the effect. Resistance drops to exactly zero at 25 degrees Celsius, independently verified by labs in the United States, China, and Europe. Current densities reach millions of amperes per square centimeter, blowing every previous superconductor out of the water. The consequences are staggering. Right now, we lose up to 10% of all generated electricity as heat in transmission lines. With these materials, power grids become free energy highways. Every electron arrives where it's needed. Desert solar farms can beam lossless power thousands of miles across continents. Electric vehicles charge in seconds and run ice-cold forever. Fusion reactors, previously crippled by resistive heating, suddenly become practical overnight. Headlines are screaming free power grids forever for a reason. And here's the detail that keeps physicists awake at night. Simulations show these 2D lattices possess topological protection, electron pathways so robust that even physical defects can't destroy the superconductivity. One lab accidentally shattered a sample mid-experiment. The fragments kept superconducting anyway, self-healing at the broken edges. This isn't just another discovery. This is the spark of an energy revolution we never dared dream of. The next time you flip a light switch, remember, the future of electricity just went super.